Hello everyone, I am Avdut Dattatreya Kalakwade and I am going to present my topic on errors, systematic errors and random errors in analytical chemistry. In analytical chemistry, obtaining an accurate and reliable result is extremely important. However, no measurement is perfectly exact. Every experiment contains some amount of error. Understanding these errors help us improve the quality, reliability and accuracy of analytical results. In this presentation, I will explain introduction to the errors, accuracy and precision, classification of errors, systematic errors, instrumental and method errors, human errors, random errors, accidental errors, methods to minimize errors, and finally the conclusion. First, let us understand what an error actually means. In analytical chemistry, an error is the difference between the measured value and the true or accepted value. The formula shown on the slide is error is equals to measured value minus true value. For example, if the true value is 50 and the instrument shows 52, then the error is plus 2. Errors can occur during measurement, observation, calculation, or experimental procedures. It is important to remember that no experimental measurement is completely free from errors. Errors reduces accuracy, reliability, and quality of analytical results. Studying errors is important because it helps us improve analytical accuracy, obtain reliable and reproducible results, identify limitations of instruments and methods. It also improves the industrial and laboratory analysis. Coming to the figure 1 of measured versus true value, this figure shows the difference between measured value and the actual value. The gap between them represents the measurement error. Now, let us understand two very important terms, accuracy and precision. Accuracy refers to how close the measured value is to the true value. If the result is very close to the correct value, accuracy is high. High accuracy means low systematic error. Precision. Precision refers to how close repeated measurements are to each other. If repeated readings are almost the same, precision is high. High precision means low random error. Here, four cases we will explain. Accurate and precise. This is the condition where values are close to the true value and also close to each other. Accurate but not precise. The average value is correct but readings are scattered. Precise but not accurate. Readings are close together but far from the true value. Neither accurate nor precise. Readings are scattered and incorrect. Now let us understand figure 2, random versus systematic error. This figure compares systematic and random errors using target patterns. Systematic errors shift all readings in one direction while the random errors scatter measurements unpredictably around the true value. Errors in analytical chemistry are mainly classified into three types: systematic errors, random errors, and accidental errors. Systematic errors. These occur repeatedly in the same directions and are reproducible. Examples include calibrations error, faulty instruments, and incorrect methods. Random errors. These occur unpredictably due to uncontrollable factors and mainly affect the precision. Accidental errors. These are sudden, unexpected errors caused by accidents or negligence. Key characteristics. Systematic errors are detachable and correctable. Random errors are unpredictable, while accidental errors occur suddenly and produce large deviations. Now coming to figure 3, classification flowcharts. This flowchart shows the hierarchy of different types of analytical errors. It explains that systematic errors affect accuracy, random errors affect precision, while accidental errors produces major deviations in results. Systematic errors. Systematic errors are also called as determinant errors. These errors occur repeatedly, remain consistent, and move in the same direction during measurements. They may be positive or negative. Characteristics. The main characteristics are they repeat in the same direction, reproducible, affect accuracy, and usually detachable and correctable. Causes. Major causes includes faulty instruments, calibration problems, and environmental conditions such as temperature and humidity. Effects. These errors create bias in measurements. As a result, readings become consistently higher or lower than the true value. Now let us look at the figure 4, systematic error direction. This figure shows that systematic error consistently deviate in one direction from the true value, creating measurement bias. Instrumental errors. Instrumental errors are caused due to defects or improper functioning of analytical instruments. These errors arise from the instrument itself rather than the analyst. Causes. The major causes are improper calibration, zero error, wear and tear, manufacturing defects, and electrical disturbance. For example, a balance reading 0.5 milligram higher or a pipette delivering 9.8 milliliter instead of 10 milliliters or incorrect pH meter calibrations. Now coming to figure 5, instrument linearity error. This figure compares the ideal instrument response with the actual response. The deviation between them represent instrument linearity error. Now let us discuss method errors and human errors. Method errors. Method errors occurs because of limitations in analytical methods and procedures. Causes include incomplete chemical reactions, side reactions, impure reagents, analyte loss, and incorrect assumptions. Human errors. Human errors are caused by mistakes made by the analyst. Example includes carelessness, improper observation, incorrect reading, or wrong calculations, recording mistakes, and lack of experience. Now let us look at the figure 6, which compares error sources. This figure compares different sources of analytical errors. It shows that method errors are related to analytical techniques, while human errors depend on the skill and experience of the analyst. Random errors. Random errors are unpredictable variations that occur during measurement due to uncontrollable factors. These are also called as indeterminate errors. Unlike systematic errors, they do not occur in one fixed directions. Characteristics. Random errors occurs without pattern, cannot be completely eliminated, and affects the precision. The value may be positive or negative. Causes. Common causes include temperature fluctuations, electrical noise, and mechanical vibrations. Coming to the figure 7, random error distribution. This figure illustrates random scattering of measurements around the true value, which mainly affects precision. Accidental errors. Accidental errors are sudden unexpected errors caused by accidents or unforeseen situations. These are also called as gross errors. Characteristics: they are irregular, unpredictable, and usually very large. Causes: example include power failure, instrument breakdown, spilling chemicals, sample contamination, and sudden temperature changes. Minimization of errors: these errors can be minimized by regular calibration, proper maintenance, careful handling, repeated measurements following correct procedures, and analyst training. Now let us understand figure 8. Methods to minimize the errors. This figure summarizes important precautions used to reduce analytical errors, including instrumental precautions, experimental precautions, human precautions, and statistical methods. Coming to the figure 9, error minimization flowchart. This flowchart explains the systematic process of minimizing errors in analytical chemistry. To conclude, errors are unavoidable in analytical chemistry because every measurement contains some degree of uncertainty. Understanding different types of error is essential for obtaining accurate and reliable results. Systematic errors mainly affect accuracy, while random errors mainly affect precision. Instrumental method, human, and accidental errors must be minimized using proper analytical techniques and careful laboratory practices. Finally, Figure 10, Summary of Errors Types, provides an overall summary of systematic, random, and accidental errors along with their characteristics and effect on analytical measurements. Thank you everyone for listening to my presentation. I hope this presentation helped you understand systematic and random errors in analytical chemistry clearly. Thank you.